Okay. Well, in this series of tutorial, we are going to start talking a little bit about fingering. Many people see fingering to be difficult subject, but it is much easy. I can tell to them, fingering have to be one of the subjects that we have to be good at because it is very easy. Fingering is very easy. So we are going to start a series of fingering in which we'll be talking everything about fingering, solving difficult questions, trying past questions, so that your examination, your final examination will be secure. The only favor that I need from you is to just wait a second of your time to just click on the subscribe button for me. And also you like it, then you share it to your friends so that you can all understand the content and move on in life. Let's get into. You will first talking about dimensional analysis. You will be just be beating our this. We'll be going straight to the important part of it. Now we start with the dimensional analysis, in which we'll be talking about dimensional equations. Now, if I'm to talk about dimensional equation, a dimensional equation here, is an equation which expresses a physical quantity in terms of its dimension. Then what is the dimension itself? Let's come to here for us to be able to understand what is going on clearly. Now, taking the dimension, and here they are saying that the dimension of a physical quantity is an algebraic symbol assigned to an individual quantity. So the dimension is just a symbol over there, and for that symbol, every physical quantity in this world have to be able to have one of these dimensional equations. Have to be able to have one of these symbols. It is very easy for you to get them. Very easy. We'll be going into all. Now, for this, we take the three important aspects of the fundamental quantity. Hope you know this from your earlier stage in education, in school. The fundamental quantity. For the fundamental quantity, where we have something like the length, mass, time, electric current, temperature, luminous intensity, and amount of substance. All these are the 7 main fundamental quantities. But for the dimension, we use the 3 main of it. Particularly 3 of them is what we use. 3 of them is what we use mostly for it. So now, let's first see these 3. And I just come here, I've just analyzed this over there, in which we have a quantity over there and a dimension. We'll be talking mainly about these 3. Nothing else. So now, the quantity mass, it is having a dimension to be the symbol. We explain the dimension to be symbol. So the dimension to be capital M, the length to be capital L, time to be capital T. So these are the dimensions assigned to this quantity. The symbol assigned to this quantity, so these become the dimension of mass, which is M, the dimension of length, which is L, and the dimension of time, which is T. So with these 3, we can be able to identify all other physical quantity, 8 dimensions, we can be able to identify all of them. Okay, in order to do this, we use symbol. If I'm to specify the dimension without writing the dimension, I use a square bracket like this. So if I just write square bracket and I put something like mass over there, let me just emphasize it. Here, I can just equate this to be capital M, where the square bracket means dimension of mass to be capital M. So everybody who understands dimensions clearly will be able to see that for this is talking about dimensions. So if I'm to bring a square bracket, L, length, a square bracket length, then I'm going to get capital L. I'm going to get capital L and another square bracket, and I bring something like time. I'm going to get capital T. So these are the dimensions. Instead of writing it like this, I can go by using the square bracket. We'll be using this mostly, so get that in mind. Now, let's look at one question and let's see how to go by it. Okay, let's look at the example over here. The question is saying, what is the dimensional equation of speed? First of all, before you can do this, you have to be able to get the formula in which we use to calculate for speed. The formula in which we use to calculate for speed. It is very necessary, the formula in which we use to calculate the specific physical quantity that was given for you to just find it. Okay, so now for the speed, what I know is that speed is equal to distance divided by time. Distance over time. This is the formula used to calculate for speed. Now, before we can continue, then I have to emphasize this. Dimension of speed is what I need, and that is going to be equal to dimension of distance divided by dimension of time divided by dimension of time. Now, I know distance to be the same as length. So distance moving from one place to another like that considered to be length, the length of a particular object. So therefore, the dimension of distance is the same as the dimension of length, which is equal to capital L, and the dimension of time is equal to capital T. So hence, therefore, the dimension of speed becomes equal to the dimension of the distance, which is equal to the dimension of length, to be capital L divided by capital T. So this one is the same, can be expressed as L times 1 over T. So when we are having something like this, we know that the top will be multiplying, the numerator will be multiplying each other, and the denominator here will be over 1, but we don't get quite it. So I will still get the same thing. Now, this one is inverse of T. So inverse of T can be expressed as T minus 1. So for that, I can get something like L times T minus 1, which is going to be equal to T, which is going to be equal to LT minus 1. For that, so the dimension of speed then becomes equal to LT minus 1. LT minus 1. It is very easy. We are having this. Let's try another example. You get it clearly. I'm having this example over here. If you get what it's about, then pause the video and try the one over there. I'm coming to explain each of them from scratch. Okay, welcome back. Just wait and compare your answer to mine and just see how brilliant you are and also the progress that you are making. Okay, so now let's look at the solution of each solution. Now for this, we are tackling the A, which is area. Area is being given by length. You have to first know the formula, length times the width. Length times the width. Now, for length and width, both of them are distant, so it can be considered to be just length times length, or because in physical quantity we don't have weight in it. We have length. That's why I'm replacing the length with this one. So first of all, I want the dimension. Go dimension of area then becomes equal to dimension of length times dimension of length, in which this length represents the width. And we know that the dimension of length, as I've explained earlier, is just L. Therefore, I'll be having area to be equal to L times L. And this L times L here is indicated that is power of number. The base are the same, so we just add the power. We are having a power 1 over here. So when we add, we are going to get L power 2. So hence the dimension of area becomes equal to L power 2. That is the final answer for the A. Okay, let's try the B and C. Go for the B, we are having it to be. For the B, let me just do it on different paper so that you can do all of them clearly. For the B is density. So we get density density. And we know that density is equal to mass divided by volume. Mass divided by volume. And now I want the dimension of density. So I'll be using the symbol which is dimension of density. Then becomes dimension of mass divided by dimension of volume. So now we are having the dimension of mass, to be very clear, which is equal to capital M, and dimension of volume. The dimension of volume is unknown, but volume can be measured with, when we take something like a cube, it is what is termed as L cube, that is length times length times length, making L times L times L, which is equal to L cube. So that is the dimension of volume, L cube. Now, for that, the dimension of density then becomes capital M divided by L power 3. Go for this one. It is very easy for you to just simplify this. It is just M L minus 3, just like that. So the dimension of density becomes equal to M L power minus 3, M L power minus 3. That is the dimension of density. The key is acceleration. So key acceleration. Oh, sorry. Why I get I'm making a lot of for my simple component. Okay. So acceleration is just velocity over time. Velocity over time. Now, here we don't know the dimension of velocity, so let's find the dimension of velocity first before we can be able to use it to find the dimension of acceleration. So for that, velocity is equal to displacement divided by time. Displacement over time. The video is getting too long. Displacement over time. So for this displacement over time, therefore, dimension of velocity is equal to dimension of displacement. Now, displacement is a distance with a specific direction, which is a vector quantity. A distance with a specific direction is what is termed as displacement. So for that case, then I can think it is a distance, then that it takes the dimension of length. Take the dimension of length, which is capital L, and the dimension of time be capital T. So for here I'll get L T minus 1, just like this. So that is the dimension of velocity, but we are after the dimension of acceleration. So hence the dimension of acceleration is equal to the dimension of velocity, divided by dimension of time. Divided by dimension of time. So for this one, I'm going to get dimension of velocity to be L T minus 1, all divided by T. Go for here, simple mathematics. It is dividing, and here is power 1. Here is power 1, and the T that is indicating it is dividing. So we are going to get the L over there and T minus 1, and the law of indicating that when it is dividing, we subtract the power. Go minus the 1 here. Go from here, we are going to get LT minus 2. Go for this. Therefore, the dimension of acceleration is equal to LT minus 2. Equal to LT minus 2. Please go through when you have any question. If like the video is getting too long, I didn't I wasn't expecting this, but thank you. We will continue on the other 2 questions in part 2. Are you getting me? Other 2 questions and other questions in part 2. So feel free to go through there. When you are having any question, let me know in the comment section below. Subscribe to our channel for more videos. Thank you.